So, what do we do when a system gets too complex to understand? Well, our first instinct is usually to break it down, right? We call in the experts, we divide up the labor, and we trust that if we just assemble all their specialized knowledge, we can get control back. But what if that very strategy is actually designed to fail?
And look, this idea isn't new at all. It's really the engine of all modern progress. Adam Smith famously argued that this division of labor leads to a massive, almost unbelievable increase in productivity. It's the promise our entire world is built on.
And for a long time, it seemed like this was the perfect solution. This relentless drive for specialization is what built our global supply chains, our financial markets, our digital world. It created a world of almost unimaginable complexity and, yeah, power.
A world that now operates completely beyond the full understanding of any single person. The very strategy we use to master complexity has created this new, pervasive kind of blindness. And here's the thing. This isn't an accident. It's a structural outcome of the system itself. To really see how this happens, let's start with something incredibly simple. A single, solid piece of wood. It's whole. It's unified. It's understandable. One person can know everything there is to know about it. Now, let's follow its journey. So, the journey always begins with this seductive and honestly entirely rational logic, the pursuit of efficiency. This is the engine that drives everything that comes next. Adam Smith had this great example with a pin factory. He said, a single worker trying to do every single task might struggle to make even 20 pins in a day. But if you break the process into these distinct little steps, one person draws the wire, another one straightens it, a third one cuts it, something absolutely remarkable happens. 10 specialized workers could suddenly produce tens of thousands. 48,000. At that point, the logic is just undeniable. To get more, you have to divide more. It stops feeling like a choice and it starts to feel like a fundamental law of how things work, with every single incentive pushing you in the exact same direction. And that is what happens to our piece of wood. It's no longer a whole thing. It is now 1,000 perfectly shaped, identical parts all ready for assembly. Yeah, it's far more useful, but its original unity, that's gone forever. But this relentless optimization, it produces its first and probably inevitable side effect. As each individual part gets more and more efficient, the system as a whole starts to lose its sight. The expert who straightens the wire, well, they know everything there is to know about straightening wire, but absolutely nothing about sharpening the point. Each specialist develops this incredibly deep but incredibly narrow field of vision. It's like they're standing so close to their one piece of the machine that they can no longer see the whole thing. Information just gets trapped in these little silos. And this is where a really strange property of complex systems starts to take hold: emergence. The system as a whole begins to show behaviors that you just can't explain by looking at its individual parts. It's almost like it develops a mind of its own. And the consequence of that, the system's behavior becomes a complete mystery, even to the very experts who built it. They can explain their piece, sure, but no one can explain the whole. It still works, but why it works is no longer fully understood. So, our wooden parts are now assembled, but not into a simple block. They're now part of a complex, interlocking clockwork. Every gear turns perfectly, but the craftsman who made those gears has absolutely no idea how to repair the mainspring. The knowledge is just fragmented all across the workshop. The problem, though, it actually runs even deeper than just what people can see. It's rooted in the very nature of the knowledge the system now depends on just to survive. So much of an expert's real value isn't in a textbook or a manual. It's what we call tacit knowledge. It's the intuition, the feel for it, the instincts that you can only develop over years of experience. It's the knowledge of how to handle all the weird exceptions and navigate problems nobody saw coming. You can't just write it down and transfer it. And the more complex a system gets, the more it relies on this unwritten, intuitive expertise to stay stable. The official blueprint might explain how things should work, but tacit knowledge is how they actually work, day in and day out. This creates an almost unbearable vulnerability. See, the system doesn't own its most critical operating knowledge, it's basically just leasing it from the minds of its experts. And when those experts leave, well, that knowledge walks right out the door with them, leaving a void that the system itself has no way to fill. So in our clockwork, imagine the one person who knew the secret to tempering the mainspring decides to retire.
You can hire a dozen new gear cutters, but the clock just won't keep proper time anymore. The system has created a single point of failure that it can't even see. And all of this leads to the final stage of the paradox. The system is now complex, it's opaque, and it's fragile. It has become a prisoner of its own success. So this begs the obvious question, right? If we can see this fragility, why can't we just fix it? Why not simply redesign the whole system to be more robust and, understandable? Because the components were never designed in isolation, they've co-evolved. Each specialized part has adapted itself to the specific quirks and requirements of every other part. Changing just one component would create this massive cascade of problems, forcing you to change everything else all at once. This is a state of what you could call irreversible specialization. The system has become so interconnected that it is just locked in. At this point, the cost of making a fundamental change is actually higher than the cost of just maintaining the fragile, broken thing we have now. Escape is no longer an option. Our clockwork is now sealed inside an opaque box. It's still running, sure, but we can't open it up to see how it works or to fix it if it breaks. All we can do is hope it just keeps on ticking. And here's the final twist. This outcome, this complex, fragile, and totally incomprehensible state, is not a sign that the system is failing. It is the inevitable result of its own success. Every single rational step, taken in the name of efficiency and progress, led directly to this exact point. The system did exactly what it was designed to do.